How do we inspire African researchers to contribute to self-driving technology? I believe the way to do this is by reducing the cost to entry, because research like this can get really expensive. This is an example. This is arguably the first attempt at a truly self-driving car. It was the winner at an autonomous race competition hosted in the US in 2005. Building this car required dedicated funding from the likes of Red Bull, VW, Intel. And as a matter of fact, there are individual sensors on the vehicle that cost as much as $20,000, just one piece. You can start to see how expensive something like this would be and how difficult it would be for a small university to replicate such research. So the desire to make self-driving research open and more accessible is what led me to design and build Rolly. This is a picture of it, and what it is a low-cost, affordable, self-driving development platform that gives students and researchers a tool to test out ideas and really build self-driving technology. So I'll go through a little overview of how the system works, the architecture. So there is a physical layer, and that consists of the parts of the vehicle that you can see and touch. There is a rover, which is the vehicle itself, and there's a remote controller. In designing the system, I try to use really affordable, low-cost equipment like the Raspberry Pi and DC motors to really bring down the costs. The same goes for the remote controller. I don't know if you have ever seen an Arduino before, but this uses an Arduino as the brain of the controller. But aside from the electronic parts, there are a set of 3D printable components that provide an aesthetic and functional way of combining all of these intricate pieces. And together, they form the entire system. This is what those structures look like when they are completely assembled. And this is what they look like when they are disassembled, when you print them. The same goes for the remote controller. It also has 3D structures you can use to assemble them. So yeah, this is what it looks like after it's been built. This is the remote controller and the rover itself. Then to the control layer. The first layer, the physical layer, are the physical components you can touch. Then the rest of the layers are conceptual software units. So the control layer has software that gives users the ability to communicate with the physical layer. Then there's perception with those with computer vision and how to interpret what the vehicle sees. Then there is the learning layer, and this is where the magic happens. This layer defines machine learning algorithms that allow Rolly to make autonomous decisions. The current system being used is something called a convolutional neural network. And what it does is it takes visual data, uses that data to train the vehicle. Then subsequently, the vehicle is able to drive itself in similar environments to what it was trained on. It's a little complex, but all you need to know is what I said. Okay, so that together forms the entire Rolly system. So whenever I give this talk, I try to make an important point to speak of why this is important. Why should Africa contribute to self-driving research? Why is it necessary? And I have two main reasons why I think it's important. The first of which is, I believe really brilliant solutions come from luck. To illustrate this point, let me tell you a story. I think a year ago, I went on a kind of pilgrimage. I picked a backpack, packed some clothes, some tools and equipment, and I went around touring the regions in Ghana. I was teaching kids robotics and how to build their own toys. I worked with kids in school, kids on the streets, and I had an amazing time. But in one village, I was approached by this guy, this little boy, and he told me that he wanted to build a car that could follow a line. And at that time, I didn't have the color sensors that we would use to build such a car. I didn't have a 3D printer to print the body of that car. So what this little boy did was he went into a nearby forest and he brought back a type of wood. It was really light, yet very strong, and it was like cork. You could push things into it. Then we used that wood with scrap metal we harvested from the village to build the chassis of the car, which ended up looking something like this. We recycled waste metal that we found around. And we had to implement the color sensors from scratch. We used what we had light sensors, and we had lights, we had resistors, and we used those to build those sensors. And what I think was interesting about this whole experience was that we would not have done that if I was in Accra, if I was in the main city. I could have just gone out and bought the parts I needed. Or I could have just used my 3D printer and printed the body we needed. But we were only able to come out with this brilliant solution because we did not have the tools that we needed to build them. And I think that is a contribution Africa has for self-driving. I was recently in a conversation with the head engineer, one of the big tech companies in Silicon Valley, and he spoke about how current big tech is just throwing money at the problem. So they buy the most expensive sensors, they spend a lot of money, build the most complex maps. And solutions like that work, but they are not scalable because of the costs. So I believe participating actively in this kind of research in Africa would introduce really cost-efficient and brilliant solutions that are then scalable to even those economies. And the next reason I think this is important is algorithmic racial bias. This is a headline from a few weeks ago in this month, and from a study that found out that the vision systems and algorithms used in self-driving cars may find it difficult to recognize people of darker skin colors. And what this means is in the future, when a self-driving car has to make a decision between hitting a person, it would choose the darker-skinned person. You know, algorithms themselves do not have biases, but often than not, the bias of the designer seeps into the algorithm. The kinds of data it is trained on seeps into the algorithm. So what better way to ensure that the end solution of self-driving is inclusive than to contribute to that solution ourselves? I would end the whole talk with a short film I did on Roli back in Ghana. But before I do that, I want to leave you with this word, Ubuntu. And this word is from old South African wisdom, which summarizes humanity and our shared purpose. And I think it ties in perfectly with the theme of the Biennale, Me, You, Nous. It talks about our existence and the fact that we exist because of each other. I am because you are, and you are because I am. So if we exist because of each other, if I am because you are, then how can we ever truly solve any of humanity's problems if we do not include and take the contribution of all of humanity?